So this is the last lesson of chapter 4. This is reversing chain rule. So when we're taking a derivative, we're using chain rule. Now we're looking at a way to reverse the chain rule. So here is what you guys remember. Remember baby mama for chain rule? This is the derivative of a composite function. So big F of g of x, where big F is the mommy function, g of x is the baby function. So what we learned before was that, no, the u substitution is not on the quiz. Okay, so by the time you guys get to the test, it will have a u substitution, but this is the u substitution part is not on the quiz. Okay, so the derivative of f of g of x we learned was take the derivative of the outside function, which is the mommy function, leaving the baby alone, and then timesing by the derivative of the baby, which was g prime of x. Okay, so now the question is, what if I see all of that as part of the integrand? Okay, and you guys have actually done some basic u substitution, but in your head at this point. The question is, oh, I didn't finish writing out the rest of that. Hang on here. So the question is, what if I saw all of that, including the g prime of x dx, inside as the integrand? And how is it that I can come up with one procedural way to do this type of problem if it becomes too difficult for me doing something like this in my head? So let me give you guys first an example of something that you've done in your head before. E to the 5x, integrate that. Okay, and don't write this one down. Okay, so you've seen some of these on your homework assignments, and it was expected that you were able to do it just, a basic understanding of reversing the chain rule. So we know the derivative of this function is e to the 5x. The derivative is itself, so the antiderivative is also itself. When I'm doing the chain rule for taking a derivative, I'm timesing by 5. What should I multiply by to undo the timesing by 5? What should you guys multiply by? Okay, so intuitively, we understood that we multiplied by 1/5. And when we check our work, if I took the derivative of that and reversed and actually checked the chain rule on that, I do get back to the expression inside, which is my integrand. Okay, so that was an example of just a basic u substitution that you guys did in your head. Okay, so over here, now I'm going to come up with the procedural for it. Okay, so u substitution you guys have seen before. You've done it when you did factoring, like complicated trinomials where it was like x to the 4th plus 4x squared plus 4. You might have used u substitutions to replace x to the 4th with x squared. Some of your teachers might have used that word, u substitution, but it's simply just to say, hey, let's let u be equal to something to simplify this problem out a little bit. And what we're going to always do is we're going to find the baby function. Okay, so the baby function being g of x. Okay, so we're going to let u be equal to g of x. And then what we're going to do is take the derivative of both sides. And when we do, we're going to take it with respect to x. But this time I'm going to say the derivative of u is du. Technically it's du dx, but I'm going to show you guys where I'm going to put the dx instead. Is equal to the derivative of g of x, which is g prime of x, times dx. Okay, so why this notation? Okay, so this is the same thing as du dx is equal to g prime of x. What I did instead was then just wrote the dx on the other side. Okay, basically times both sides by the differential dx, and then just wrote it as du equal to g prime dx. And here's the reason why. When I now look at my integrand that I'm trying to replace with everything u, so everything x here, I'm going to replace with u that I see below there. So if I rewrite this, so we're going to rewrite in terms of u. I have the integral of f prime. Okay, g of x is equal to u. Okay, and then I want you guys to look at this part here, which I'll use a different highlighter for. You guys, can you tell me in terms of u, what is g prime of x dx? In terms of u, what is g prime of x dx? Do you guys see that down below there? It's du, exactly. So now I have the integral of f prime of u with respect to u. So I want to see u here, and u being the independent variable inside your integrand. Okay, so what's the trick question here? I think I asked this trick question at the tutorial. What's the antiderivative of f prime? What's the antiderivative of f prime? F. Good. So the derivative of f is f prime. So antiderivative of f prime is f. I promise you guys I did not pick these letters to be the way they are. But when you take the antiderivative, the general antiderivative, and you don't have a definite integral, you have to add a what? What else do you guys have to add? Again, not my choice of letters. This is u substitution, add a constant, but you let's just not, and I thought, okay, well, what if I added a k instead of a c for standing for constant? Still get the same problem, right? So so what we're going to do now is that's the general process in which we do it. And there's a couple of different things that occur when we do this. So let's say example number 1. We're going to do the integral of x squared plus 1 squared 2x. And some of these, I know some of you will be able to just simply do u substitution for some of the basic ones in your head. But we're going to practice the process of it. And I've shown both process, whichever way you guys feel most comfortable with. Okay, so we're going to first start with letting u be equal to the baby. Okay, so my tip to you guys, I think u substitution is harder than integration by parts, to be honest, because of this step right here. What do I let u equal? So what you guys have to get used to is you're going to let u be equal to the baby function. And in your head, you're going to think, okay, the derivative of the baby, do I see the derivative of the baby within the integrand anywhere? And so if I think, okay, well, let's let u equal x squared plus 1. That's the baby function. If I take its derivative, I do notice that the baby function is right here, the 2x. Okay, so then I know I'm on the right track. Okay, so let's keep going with this. So du is equal to 2x times dx. Okay, so right away, you'll notice that this falls in line with what you guys saw above. And one way of doing this is recognizing that this is all of that is du. Okay, so then going back and doing your u substitution. Well, if I need everything to be u, the baby function is u, so u squared. 2x dx is du, so du. And the point is, can we make the integrand a little bit more simple so that when I find the antiderivative, I can do so using just basic antiderivative rules? So what's the antiderivative of u squared? We would keep the u cubed over 3. This is an indefinite integral, so don't forget the plus c. And remember that the initial question asks for an integral with respect to x. So at the very end, after you guys find the antiderivative, you just like you've done u substitution for other problems before, you're going to resubstitute x squared plus 1 back into there. So my answer is x squared plus 1 cubed over 3 plus c. Okay, and then you guys can always check your work, do the derivative in your head, do you get back to the integrand? And then you sure do for this problem. Okay, the other thing I wanted to mention is sometimes it's not so easy to spot this du part. It's not so easy to see that this is du. So I wanted to make this part, I'm going to do it in a different color. This is an alternate way of doing this step right here. Let's say you guys got up to here. So this is, let's say, alternate. So you still do u equals x squared plus 1. You still do du equals 2x times dx. But some students prefer to solve for dx. Okay, so if you solve for dx, that means divide both sides by 2x. So you get dx equals du over 2x. Why do that? Well, I'm going to start doing that for more complicated problems. But the nice thing of doing it this way is after you guys get to the part where you're now trying to substitute everything in, you're going to substitute the baby function as u, just like we did on the other problem. And then 2x, we can't do anything to. So let's say 2x we're going to leave. But then dx is this expression right here. So that's going to replace this dx right here, du over 2x. And what we should see happening when we do it this way is that the derivative of the baby function should cancel out. And then we're left again with the same expression as we had on the left-hand side, a third u cubed plus c, and then our final answer should be the same here. Okay, so as we get into more difficult and complicated, complex use substitution, I think the alternate way is a little bit easier just because sometimes it's not so easy to recognize the expression for replacing du. Okay, so let's try a different one. This is going to be, I'm going to switch now to a definite integral. And one that students kind of have difficulties with is recognizing it when there's maybe like a grandma function involved, and so it's a little bit harder to spot. And then also adding in the idea of how do I do this with a definite integral. I wrote in there x equals 0 and x equals pi over 2. Your problems are going to start off just as 0 and pi over 2. So how do I know that it's x? Whatever you're taking the antiderivative of with respect to, in this case, x, those limits of integration will be with respect to the same variable. So understanding that whatever you guys began with, the variable here is the same measures that you guys would use for your limits of integration, x. So here's my question to you guys. What do you think you let u equal to here? What do you think you should let u be equal to? Good, Brandon. And again, what do I do? What's my process of thinking for this? I should be thinking, what should I let u be equal to such that if I were to take the derivative of that, I would see its derivative somewhere there and be able to cancel something out. Okay, so in this case, let's say you guys, so good, the people who typed it into the chat are correct. Let's say you guys were like looking at that and you're like, okay, let me let it be equal to 3x. If you let it be equal to 3x, which is essentially the baby, then the mommy is like sine, and then you have the squared. The problem is that that's not going far enough because the derivative of 3x is just 3. That's not going to help us replace this to make it any more simple. So we want to go bigger. We want to maybe move up a generation. And in this case, some of you guys suggested sine. The derivative of sine is cosine, and I see cosine there. So we want to be able to see the derivative of the baby function here so that I can cancel it out eventually. So let me undo that highlighting. So let's begin there. And this is, again, just a matter of practice in recognizing what to do here. So let's say we let u be equal to sine of 3x. The derivative of u is du. The derivative of sine, again, this is chain rule. So the derivative of sine is cosine of leave the baby alone, and then times by the derivative of the baby, which is 3. And then times dx. Okay, for this particular problem, I'm going to now start to do the u substitution. I would recommend when you guys are doing the definite integral that you keep these as x's for now, and then I'll talk to you guys about what to do with these limits of integration. Right now, just focus on how do I find the antiderivative. Okay, so what is this, you guys? What's this expression in terms of u? What's sine squared of 3x? Okay, that's equal to u squared. Okay, now that we got like a constant going on in our du expression, and I don't want you guys to mess up on that part of it, like is it 1/3 or is it 3? What I'm going to do is with this expression, I'm going to solve for dx. If I solve for dx, I'm going to divide both sides by 3 cosine of 3x. Sorry, I squeezed that in there, but basically dx is equal to du over 3 cosine of 3x. Okay, so for the moment, I'm going to leave cosine of 3x, understanding that if I pick the correct value expression to set u equal to, that part of it should cancel out. So cosine of 3x times the expression for dx is du over 3 cosine of 3x. stop, pause. Did I lose anyone at that step? Again, I solved for dx. I left this part of it alone. And then all of this is just simply dx. Okay, so again, if we do use substitution correctly, if we just think of it procedurally, the procedure should allow for us to cancel out any terms that have x's. And what's remaining, now you guys have du over 3, or 1/3 du, or pull the 1/3 all the way out to the front. So we're going to pull 1/3 all the way out to the front. We have x equals 0, x equals pi over 2. We have u squared left, and then just du, which is what we want. We just want the expression in terms of u. So I want you guys to pay attention to this, and this is going to be important for your test and for the AP test. Sometimes what they do is you have to understand both ways of doing the problem from here. Okay, so you have a problem here. You have the antiderivative with respect to u. Your limits of integration are with respect to x. Okay, so one of the methods that we're going to make sure you understand how to do is, one choice is change the limits of integration so that they're with respect to u. The other is change this at the very end so that it's x like we have been doing, and then do the substitution then. So let's say we do method 1 at this point. And the reason why it's important is because it shows up on the multiple choice as options. Sometimes they don't even have you guys do anything yet where they evaluate it. I think there was a question that pops up. Is du supposed to be over 3? Yes, it is. And I pulled the over 3 out as the 1/3. I pulled the constant out. It's just like 1/3 times du, so just pulling it out. Okay, so let's say method 1, this is you changing limits of integration. Okay, so we're gonna keep the 1/3, that doesn't change. Okay, so if I change the limits of integration, what that means is that I want this to be u something. Well, if I know that x is equal to 0, I'm gonna go back up to here. Here's the relationship that I had set at the beginning for u and x. If I plug 0 into here, you guys, what's the lower limit of integration in terms of u? U should be equal to what? Okay, good. Many of you guys responded 0 because sine of 0 is 0. Can you guys tell me what would the upper limit of integration be? What would the upper limit of integration be? All right, perfect. And notice that I made that transition of writing u equals 0, u equals -1 to consciously, so that I'm conscious of the fact that I actually made the substitution, I changed it, and then everything else now is done nicely in terms of u. So we just do u cubed over 3 is the antiderivative. Keep in mind that you guys still have that 1/3 out front. And then we have u equals 0 to u equals 1. So go ahead and evaluate the rest of the way and then type in what you guys think the answer is. Yes, thank you, Brandon. I fixed it on when I caught it. U should be equal to -1, you guys. Oh, and then if you guys are typing in your answer, did you guys add or did you guys multiply? Thank you. Okay, and then I noticed that some people they pick a method and they go with that method. That's great, but I need you guys to understand why it makes sense that you guys do it both methodologies. Someone asked, why is u equal to -1 as the upper limit of integration? The reason is, again, we're replacing this. So when I took x and I plugged in 0, I got sine of 0 is 0. when I took the upper limit of integration and plugged pi over 2 into here, it's sine of 3 pi over 2, which is -1. So I replaced this with u equals -1. So down here, I just forgot to, I wrote it here, but then I forgot to write it here. Okay, so method 2 is basically we are going to just pick up from where we had the issue. And where we had the issue was right here, where there was a discrepancy between the limits of integration being x and then this being u. So for this one, we're just going to say, okay, I'm just going to ignore the limits of integration for now and just do my antiderivative. So 1/3 times 1/3 u cubed. So basically the same antiderivative as I have here, right? I'm just copying that. And then keeping in mind that I have this is x equals 0 and this is x equals pi over 2. So method 2, you guys can say keeping things x. Okay, and the reason why is, let's say you kept the limits of integration as x, just understanding that now after you found the antiderivative, going back and then replacing your antiderivative that has u in it with what u was equal to at the beginning in terms of x, so sine of 3x. And then cubed. And can you guys verify that you guys get the same answer, that it makes sense to you guys that you would get the same answer here? Okay, and then just, can you type in yes or no, that makes sense, that we get to the same answer? Okay, and again, sometimes the AP test doesn't give you a choice. Sometimes people like the left method, some people like the right method, and then they find that the AP problem, the multiple choice is set up. They don't even ask you to find the antiderivative. They play around with the limits of integration, and they just test your understanding of both methods.